The difference between workflows and agents is really more of a definition question and not so much a hard boundary, at least in many cases. Because in this section, we'll dive into all the essential building blocks you need to know no matter which kind of AI automation you're going to build in the future, no matter if it's just a workflow or an autonomous agent. Now we'll start by taking a brief look at no-code versus with-code solutions, though this course here is all about writing code. It's not about no-code solutions, but I want to show you this alternative as well. But thereafter, we'll get started. We'll explore how you can use large language models programmatically, specifically how you can interact with OpenAI's models programmatically. That'll be the example API we'll use throughout this course. But we'll also explore how you could use open, locally running large language models instead of those proprietary models offered by OpenAI, Google, and so on. And whilst the focus of this course will be on those proprietary models, and whilst I will use those OpenAI APIs in pretty much all examples, you will also learn how you could replace those paid proprietary models with open, locally running alternatives depending on your workflow. We'll also explore how we can work with structured input and, more importantly, request structured output by AI models and what that exactly means. And we'll explore how we can manage the control flow of a workflow, how we can run steps conditionally or repeatedly. We'll also see how we can add a human to the workflow, for example, to request extra feedback at a certain point in time. And we'll also take a look at integrating third-party services. We'll make sure that our workflow can also send Slack notifications, for example. So, plenty of topics to cover. As mentioned, it's the foundation you'll need for the next course sections as well. And therefore, let's not waste any time. Let's dive right in. So let's start by taking a look at how we can build AI workflows and agents. And here we got two main options, two different approaches for building workflows and agents. We can either do it without writing code or with code. And the difference, of course, is that for no-code approaches, you don't need to know how to write code, obviously, because that's the entire idea here. For with-code approaches for this course, therefore, you do need at least some basic programming knowledge. By no means do you need to be an expert, but basic knowledge is required. Now, when it comes to no-code approaches, there are many tools available. For example, N8N is a very popular one. And attached, you'll actually find a link to a resource that gets you started with using N8N to build no-code workflows and agents, in case you're interested in that. I also cover this in my complete ChatGPT and generative AI course, where I dive deeper into working with N8N and AI in general. But for this course, we'll focus on the with code part. But of course, there you can also use any programming language you want. You're not limited to one specific language. Now, speaking of limitations, there are some when using the no-code approach though, because there you're limited to the features provided by those tools. Now, to be fair, these tools are quite capable, but certain goals or tasks are actually easier to achieve and implement with code, if you know how to write code, than without code, because you have full flexibility and no limits if you know how to write code. And that's therefore, as mentioned, what we'll focus on in this course. But as also mentioned, attached you find a resource that also gets you started with the no-code approach in case you're also interested in that. Now, as you know, this course is about building workflows, AI workflows, and AI agents. That's what we'll focus on. And therefore, we'll need to access AI models, large language models programmatically, because we'll write code and we want to use these models in our code. Therefore, it's important to understand that there actually is a difference between a large language model and an AI application that leverages a large language model. Because typically, as an end user, you don't directly interact with a large language model. If you're using ChatGPT, if you're asking a question there, you're technically not directly sending that message to a large language model. Instead, you interact with an application that uses a large language model internally. In case of ChatGPT, you're interacting with the ChatGPT application that was built by OpenAI. And that differentiation is important because the AI application, ChatGPT, for example, contains both application logic, so the code written by you if it's your application, or the code written by the OpenAI engineers if we're talking about ChatGPT. And that logic can be about all kinds of things, like parsing the user input, managing a chat history, maybe interacting with third-party services to fetch something from Dropbox or to get an email or send an email. It might generate documents and do anything you want if it's your application. But that anything you want part also includes interacting with a large language model. And ChatGPT, the ChatGPT application, does that internally. It interacts with OpenAI's large language models. And you can do that too. In ChatGPT, you can actually tell the application with which model it should interact. If you're building your own AI application, and AI-powered workflows and AI agents are just AI applications in the end, you therefore also might want to interact with a large language model. You actually need to if you want to integrate AI. And therefore, you interact with models provided by OpenAI, Google, xAI, Anthropic, or any other provider. And you do so by using their APIs, which means you're going to send requests to their servers, which then trigger their models under the hood, and you'll get back responses generated by their models, which are running on their servers. And all these providers, OpenAI, Google, and so on, they offer APIs you can use and you can interact with to interact with their models through these APIs. And you'll find detailed documentation by each provider for their APIs and how to use them. You'll find details on which models you can use through their APIs. You'll find details about the pricing, because using these models by these providers is not free. These are paid models, so you're paying for all the tokens you're sending to them and for all the tokens you're getting back from them, and I'll get back to that. And you'll find instructions on how to interact with their APIs, often for different programming languages, but also for generic requests, which you can send from any programming language. And that is what we'll take a very close look at over the next lectures, because that's exactly what we'll do. We'll send such requests to interact with those APIs. And that's therefore how you build AI applications and how you build AI workflows and agents. You have your logic, and then you reach out to some large language model provided by some provider like OpenAI through their APIs. Now, when it comes to using large language models in your own applications, there actually is an alternative to using the large language models provided by OpenAI and so on, for which you have to pay, which I showed you in the last lecture. You can use these proprietary models, but you can actually also instead use open models. Now, these proprietary models are the models that are hidden behind the APIs provided by these providers, so which can only be used through their APIs and where you have to pay for the usage. And OpenAI, Google, Anthropic, they all offer their own proprietary models through these APIs for payment, so you pay for the usage. You can't run those models locally. Now, to be fair, it would be hard technically too, because these are large models that need really powerful, very capable machines and PCs. But even if you had such an extremely powerful computer, you would not be able to access those models because they are proprietary. They're not available for public access except by using their APIs, where you have indirect access to them. Now, that also means that you have less or maybe no data privacy because you have to send all your prompts, all your questions, all your data to their servers for every single question you have, for every single interaction with the large language model. And therefore, you have only very limited control over what they do with that data, and it definitely leaves your machine for that request. Now, open models are a popular alternative. Specifically, we're talking about open weight large language models, which means these are large language models that have been trained by certain companies like Google or Meta, but also the DeepSeek model would be a very popular one. These are models that have been trained by companies, and these companies then published the results of this training process, the so-called weights that make up the large language model. The great thing is that you can run these models locally, for example, with help of tools like Ollama, which is a tool that's available for macOS, Linux, and Windows, which you can download to your system, and I'll show you how that works in the next lectures. And then you can use this tool to run all kinds of open large language models on your system. And what's really great about these open models is that most of them are published in different sizes, so with different amounts of parameters. Now, in general, you can say the more parameters a model has, the more capable it is, but even models with a low amount of parameters can be great at certain tasks like summarizing text, understanding text, or generating text based on some other input text, as you'll also see in this course here. And that's important because this number of parameters, which here is shown in billion, is related to the amount of computer memory this model needs in order to run on your system. And you can roughly double these numbers and take the result in gigabytes to have an estimate for how much memory you need. So to run a 1 billion parameters model on your system, you will typically need around 2 gigabytes of memory, preferably GPU memory. So the larger models, especially if you have hundreds of billions of parameters, are typically very hard and difficult to run on your system because you typically don't have the hardware for that, but smaller models can be run there. And again, as you'll see, they are often more than good enough for many of the tasks you might want to perform with help of large language models. And Ollama makes running such models on macOS, Linux, and Windows a breeze. And it's also worth noting that Ollama isn't the only option. There also are other tools, but Ollama is amongst the most popular options. And actually, I got an entire course where I dive much deeper into running such open weight large language models on your computer. But in this course, we'll also use them as an alternative to the proprietary models. Because the advantage here is that they are, of course, free to use. You don't have to pay for the usage, and you got 100% privacy because you're not sending any data to any servers. Instead, it's all running on your own computer or on your own server, for example. Now, to be very fair, it's important to recognize that the best models, which offer the best performance, are typically the proprietary ones. But there also are very capable open models available. For example, DeepSeek R1 is a good example for an extremely powerful and capable open model that was published in early 2025. And there are many others as well. But there are also smaller models, which is important. Otherwise, you wouldn't be able to run them on your laptop, for example, if they take up too much memory. There are smaller models available, which are maybe not as powerful as the best proprietary ones, or like DeepSeek R1, but which are more than good enough for many of the tasks you want to perform, as you'll also see in this course here. And therefore, that's an alternative you should know about, and an alternative we'll also use in this course, besides some proprietary models, because it is an interesting alternative, which does offer significant advantages. Now, in order to finally write some code, we of course need a development environment that allows us to write code. And for this course, I'll use the Python programming language because it is extremely popular in general, but also especially for AI-related development. It has a very simple syntax, it's easy to learn, and therefore it's perfect even if you don't know Python or if you don't know a lot about Python. That's no problem at all if you got some programming experience, some knowledge which you need for this course, no matter in which language, then you'll be able to follow along with Python as well. And of course, what you'll learn in this course can also be applied to other languages because you can access all these models, proprietary and open, not just through Python, but in the end, through any language you want, because we're just going to send a bunch of HTTP requests to various APIs. Now, we'll also need a code editor, and for this course, I'll actually use VS Code and Cursor. VS Code is an amazing free code editor that's available for all operating systems. Cursor is not really available for free. It's very limited if you don't pay for it, but it's also totally optional. It's just an amazing AI-powered editor which can make writing code a bit easier, but it's absolutely not a prerequisite for this course. And then, as mentioned, to programmatically interact with large language models, we'll need to interact with some models through APIs or with locally running models with help of Ollama, and we'll do both in this course. Now, when I use proprietary models, I will use OpenAI's models, so the GPT models. And that's, of course, totally optional. Again, what you'll learn here will apply to all models. You can interact with all models. You'll just always need to take a look at the documentation of these models and the APIs provided by these model providers to understand how you can use these models, which kind of parameters you can tweak, and so on. But for all the examples in this course, we'll use OpenAI, APIs and models, or the locally running open large language models with help of Ollama. So finally, let's get started writing some code. And for this, I'm in a brand new empty project, empty folder, opened up here in Visual Studio Code. And I'll start by creating a Python project by running UV init using the UV Python project and package manager. Now, UV is a tool you won't have on your system by default, but you can install it on all operating systems. Attached, you find a link to the official installation instructions. And the great thing about this UV tool is not just that it's free to use, but that it's an extremely capable Python package and project manager. It'll automatically create and manage a virtual Python environment on a per project basis, ensuring that any third-party dependencies you install don't pollute your global Python installation. It's extremely fast and overall just an amazing tool. Therefore, as mentioned, attached you find a link to the installation instructions for macOS and Windows. And once you got that tool installed, you should be able to run UV init to create a new Python project. Of course, you can also create a Python project in any other way you want, though, because we won't really use any more advanced UV features. We just need a Python project here. So out of the box here, I got a project with a bunch of files, most importantly, a main.py file, which is pretty empty initially. And I'll use this file as a foundation now to build a first basic AI-powered workflow. We'll build this first AI workflow using the OpenAI API, so using a proprietary model. And I'll get you started with how to interact with this API and the core things you can do with that API. Now, in order to access that API, you will need an OpenAI account. That can be your ChatGPT account, but typically you'll visit platform.openai.com, and then there you can sign up for an OpenAI developer account, so to say. Now, you will need to pay for using OpenAI. So you will need to buy some credits the first time you sign up here for example, $5 in credits. And once you did that, you can go to your dashboard when you're logged in, and there you'll be able to monitor your usage. So how many requests you send, how much you interact with the API. You can also set a budget here, which is independent from the credits you bought. But here I'll edit my budget and edit this to set it to just $5 to make sure I get alerted if I approach this budget here. Under billing, you can see your current credit balance. Here I bought $5 in credits. And you can, of course, enable auto recharge or buy more credits once you need them. And back on the documentation page, where you find detailed instructions for all the different APIs OpenAI offers and what you can do with them, there you'll also find a pricing page where you learn how much you're going to pay for the different models. And you'll always have input and output tokens here. And these prices then are per 1 million tokens. But of course, they're not just charged in 1 million chunks, but for every single token, but then only a fraction of that is charged, of course. And you can see there are some models which are super expensive. And of course, these prices will change over time. So by the time you're viewing this, the models and prices will already have changed very likely. But you will see that some models are cheaper, some are more expensive. Of course, some models are more capable, others are less capable. So it really comes down to choosing the right model for the right task to avoid spending unnecessarily much if you don't need it. And we'll also explore that in this course. It's also worth noting that, as I mentioned, you could use other APIs, other models by other providers as well. For example, you could use Google's Gemini models through the Gemini Developer API. And in that case, you would need to create an account with Google, and you should also visit their documentation, their pricing pages, and so on to learn how you can use their models and their APIs. Because every API works a bit differently, typically different parameters, different options that can be sent. And therefore, it's definitely important to take a look at the detailed documentation for the API you plan on using. Though I will mention that many providers, like Google, for example, actually also offer at least some OpenAI compatibility, which means you will be able to send requests in a way that's very similar to how you send requests to OpenAI, even though you're not interacting with OpenAI, because OpenAI has shaped the de facto standard interface for interacting with AI models, and that's why many providers offer some degree of compatibility. And again, the official documentation of these providers is the best way to learn more about that. Here, I'll focus on OpenAI. Now, as a last step, you will also need to create an API key, no matter which provider you're using. And that API key is, in the end, your way of authenticating with that provider from inside your code. Because soon we'll start sending requests from inside our code. And of course, we need some way of telling OpenAI, Google, whichever API we might be using, that it's us who already paid our $5 here. And we do tell the API that it's us by using a unique API key that's unique to us. And you can always create more API keys if you need them, like demo. And it's then this key which you'll need to copy and use in your project. And of course, any API keys you'll see in this course will be deleted by the time I'm done recording, so you don't even need to try them. Because, and that's important, if anybody gets access to your API key, if you accidentally share it, if you, for example, push it to GitHub, then those people can send requests to those APIs, to the OpenAI APIs, for example, on your behalf. And you will be paying for that. So you want to avoid that. So make sure you never accidentally expose your API keys. And if you do, definitely make sure you delete them as soon as you notice that you shared it so that it can't be used anymore. That's also important. Okay, and with all of that out of the way, we can now get started writing some code here and build our first AI workflow. So to get started here, I'm in my main.py file, and in there I want to build a very simple workflow that will in the end take some user input, then use an AI, a large language model, to generate a post for X, so for the X platform, and then I want to output that post so that I could then copy and paste it and share it on X. Now, that's of course not the most amazing workflow ever. We'll see more complex and useful workflows later in the course, but it's a great first workflow to get started and to learn how to interact with the OpenAI API. So as a first step, I will get the user input by using the input function in Python. What should the post be about? And I have this very specific message, what should the post be about, because I'm not building some random chat app here that should be able to handle all kinds of questions and inputs. Instead, I'll build a specialized workflow that's only about producing X posts. It's not about chatting with the AI in general. That's why I have this very specific question, and everything in that workflow will be optimized for generating X posts. That's important. That's a crucial difference between building a versatile chat application like ChatGPT, which you could also do, and a specialized workflow which aims to perform one single task with or without AI. In this case here, with AI. So we got the user input. The next step now is to generate an X post with help of AI. So I'll add a new function here, generate X post. And here I got my user input, which will be a string. And adding types like this is optional, by the way. It is a feature of modern Python, but you don't need that. And I plan on getting back a string here. And then in here, we need to call our large language model, send this to the large language model. And we'll do that soon. For the moment, I'll just pass. And then down here in main, I'll get my X post by calling generate X post and passing my user input to it. And thereafter, I'll output this. And actually, I'll split it across multiple lines here, like this. So that's the plan. Therefore, this here is now the important part, because now we want to reach out to a large language model. As mentioned, I'll use the OpenAI API here, and therefore a good start is to take a look at their documentation, because as mentioned, that's always what you should do as a first step. Now here in the overview page, I get a first impression on how I could send a request. Here using the curl tool, which is a tool that comes pre-installed on Linux, for example, but the shape of this request shows us how we can in general send it with help of any language and any library we might be using in any language. So here, for example, the goal would be to send a request to this address, which is the address of the OpenAI API. Then we would specify that we're sending some data formatted as JSON. We would include this authorization header, which includes our API key, which is important. If we forget this, we will not get a response, not a success response anyways, because we need to authenticate and tell OpenAI who's sending the request. And then we would attach some data where we specify which model we want to talk to. And again, that is important, also from a pricing perspective. And we would send our input, our prompt. Now, you can also send more complex prompts. You can see that if you dive a bit deeper into the documentation. You can, for example, send an entire history of messages, where you can also include developer or system messages, as they used to be called in the past, that provide some general instructions to the model. You could also send an existing chat history that may include past responses by the AI, so that the overall context is available to the AI for the new response it will generate. Because, and that's the important part here, for every request you're sending to the model, you start a brand new session with it, so to say. So it doesn't know anything about past questions you might have sent. If you send this input, it won't know anything about prior conversations you had with it, unlike ChatGPT. But that's the case because ChatGPT is an AI application built by OpenAI, as explained before. And therefore, it's this ChatGPT application that, for example, manages the chat history. And it's this application that always sends this entire history to the large language model, which, as mentioned, is something you can also do. But you are in the driver's seat. You control what's sent to which model. That's the key takeaway here. But first things first, I want to send a request like this. So, as a first step, I will actually install a library, which I can do with UV add here, since I'm using the UV tool. And the library I want to install is the requests library. Of course, if you're not using UV, you can also pip install requests, like you probably did in many other Python projects before. So here I'll use UV though, and install this requests library. And with that installed, I'll import requests here, and then send my request here. So I'll get back a response by sending a post request, because you actually need to send a post request to the OpenAI API. And the URL to which I want to send the request is this URL here. Now, just as a side note, the OpenAI API actually changed over time. In the past, there also was another API available, and you can still see that, at least at the point of time where I'm recording this, if you dive into the documentation, and then you might have a drop-down here, which allows you to switch between the responses and the chat completions API, which is the previous standard API, so the old API format. There, the URL was different. It was API, openai.com, and then at the end, /chat/completions. And the way you would send data to it also differed. Now, with the more modern, newer responses API, this is the address you send the request to, /responses, and the format of your data also changed. Now, in many guides, you will see the old API format, and AI tools like GitHub Copilot also may suggest the old API. You can use it, but the recommendation is to use the modern one. So this address, which you find in the documentation, the responses API. So that's what I'll do here. Now we also need to attach some data to this request, which with the requests package can be done by specifying the JSON parameter. So that will be the payload of my request, which should be a dictionary. In there, we need to specify a model, and I'll fill that out in a second, and my input. Again, I could send a more complex chat history if I wanted to, but to get started, we can also just send an input string, just a simple prompt. Now, I'll also fill that out later. It's then this payload that should be added here as data to this request. I'll split this across multiple lines to make it a bit easier to read, like this. Now we also need to add some headers, which again will be a dictionary of headers we want to add, so metadata we attach to the request, and that will be the content type header, and then this authorization header, which includes the API key. So the content type header is of course straightforward. The authorization header is a bit more complex. It is Bera as a hard-coded text, and then our API key. And that's the API key you find in your dashboard once you're logged in. So here I'll create a new one. And again, it will be invalid once you're viewing this. So I'll copy it here. And then of course I could paste it in here. And that's how that looks like. It's not a good idea to put your API keys directly into your code though, because again, you shouldn't share it with anyone. And of course you will often share your code. So having the key in there is not a great idea. Instead, what's typically done is that you add a .env file, an environment variable file. And in your gitignore file, you make sure that this is not included if you're using Git for version control. So that this env file is not pushed to GitHub, for example. And then in there, in this .env file, you can set up a variable that might be called OpenAI API key, and then store your key here, but this will now only ever live on your system. It's not pushed to GitHub, so that's why it will be saved. And then you can use that key in your main.py file through that environment variable. Now, to make sure that this environment variable gets loaded, you want to install an extra package, which is called python.env. That's a package that loads .env files and puts the environment variables that are defined in those files into your actual environment so that they're available in your code when it runs. With that installed, what you would do is you would import from .env the load.env function, execute that at the beginning of your script so that it runs as the first thing, because that is what will load those environment variables. And then with that done, you can access your environment variables. So here I would now get my OpenAI API key by using Python's built-in OS package. And then there is a getEnv function which can load the value of an environment variable into this program. The name here, OpenAI API key, of course must be the same as you specified here though. With that, that will be available, and now OpenAI API key can be used here like this. And that's now the base setup we need. Now we can work on the model and the actual prompt. Now, for the model, pricing, of course, matters, and the power of that model, so to say. And it simply depends on the task you want to perform, how capable the model must be. Now, of course, when it comes to OpenAI, all these models are quite good, but some are better, of course. O3, for example, this model is better than 4.0 mini. And you can tell that it's better because it's way more expensive. This costs $2 per million tokens, input tokens. O4 mini is just 15 cents. So it depends on the task you want to perform. For example, if you want to summarize some text, a small model like 4.0 mini is typically enough. If you have a complex planning task that benefits from reasoning and advanced thinking, so to say, a more complex model like O3 or maybe even O3 Pro might be needed, though that's really expensive. For my example here, I'll go with GPT-4o. It's more expensive than 4.0 mini, it's also a bit more capable, and actually even more expensive than O3, but not as expensive as the advanced thinking models. Now, it is totally up to you which model you want to use, and by the time you're viewing this, some of these models and prices will already have changed. At least that's quite likely. So it's always up to you to decide which model you want to use. And OpenAI, for example, actually even has a guide that helps you with selecting the right model, which you find attached. You also might want to take a look at that. So in my case, it will be 4.0 this year, and I'll copy that, this identifier, and paste it here. So this identifier here should match this identifier. And now we can work on the prompt. Now, the prompt could be our user input, which we received, right? But that actually would be wrong because we're not building a generic chat application. Instead, we're building a specialized workflow, as I mentioned before, which means it aims to do one thing and one thing only, but do that one thing well. So what we're getting here is actually the topic a post should be written about. So what the user will enter in response to this question is something like, open large language models like Gemma are amazing because they allow you to run large language models locally on your laptop. Which is not really a great prompt. It's a statement, not a question. But that is what the user would probably enter when getting asked for a topic the post should be about. So the prompt we want to send to the model should actually augment this initial user input. So I'll add a new prompt variable here, and use a F string, which allows me to dynamically inject content into this string, just as I did it here with the OpenAI API key, and use triple quotes so that I can conveniently write a multi-line string here with line breaks without messing anything up, primarily for formatting reasons. And now we want to craft a prompt that's optimized for this workflow. We want to do some prompt engineering here. It is an important skill. It's also a skill I talk about in my ChatGPT and Generative AI Complete Guide course, but it's in general important also in building automated workflows as we're doing it here. For example, we can assign a role. You are an expert social media manager, it's not too bad, and you excel at crafting viral and highly engaging posts for X, so for the X platform. I'll also add formally Twitter here to provide some extra context to the model, which has been trained based on past data, a lot of data where X was called Twitter. So I'm providing this context to make it clear that X is Twitter. Because again, in the training data of the model, it's likely that many posts it saw were actually tweets on Twitter. So that's a role I want to assign here. And then I want to provide some instructions. Your task is to generate a post that is concise, and that all sounds good, and tailored to the topic provided by the user. I will also say avoid using hashtags and lots of emojis. A few emojis are okay, but not too many. Yeah, that sounds good. Keep the post short and focused. Structure it in a clean, readable way using line breaks and empty lines to enhance readability. And then, very important, we have to insert the topic provided by the user. So actually, I'll rename user input here to topic because that's a more meaningful parameter name, because in the end, what we get here is a topic entered by the user. And then I'll say, here's the topic provided by the user for which you need to generate a post. And then what I like to do is add delimiters like topic, XML tags here, which is nothing you have to do, but something that often helps the quality or which helps produce better results with large language models. That is something I experienced and something you'll find in many guides and best practices out there. You could also use other delimiters like triple dashes, for example, to clearly separate the user input from the rest of the prompt, but I like these XML tags. Again, technically they're not required though. And then here I'll insert that topic. And that's now the actual topic we received as a parameter. And this is now the overall prompt that should be sent to the GPT-4o model through the OpenAI API. Now we'll get back a response here, and of course, in order to extract data from that response, we need to understand its structure. Thankfully, that is again something where the official documentation helps us, though here under text and prompting, I see an example response I might be getting back, or a part of that response to be precise, because here we learn that we'll get back an object that has an output property. And in this output property, we'll have an array of objects, of dictionaries in Python, where every dictionary has some data inside of it, like, for example, a content key, which again contains an array, and then in there we have objects with the actual text we got back from the API and from the model, therefore. And this response has such a complex shape because you could potentially also get back more complex responses if they, for example, include both text and images. For now, we only expect to get back some text though. So we should be able to get the response text by calling the JSON method on this response object. That's a method provided by the requests package, which we're using for sending the request to extract the received response data and convert it into a Python object. And then we can call get on that received dictionary, which we get in the end, and get the output property, because that is what we learn here, that we have such a property. And then in there, we will have this array of dictionaries. So in there, we can access the first element, because right now we only expect to get back one message. This will then be a dictionary where we'll have a content key, which will hold another array. So I want to access content. And then since this is another array, I also want to access the first element in there, which will be this element here. And there we'll then have a text key, which holds the actual text response. So here I want to get my text. The default value here for content, if nothing is found, should be an array with an empty dictionary inside. So that's how we can extract the response. And we'll also see an alternative way of interacting with the API, which is a bit easier later, but this is the bare bones approach that works with any language because we're just sending a request, and that is what will always happen under the hood, even if you are using a simpler approach later. So now here I just want to return my response text like this, and that should then be that X post which we output here. And with that, we hopefully now have a finished first basic program which takes some input, generates an X post, and outputs that X post. So now, to see it in action, I'll open my terminal and now run this Python program by running python main.py or python free main.py if that doesn't work for you. Or here, since I'm using UV, I can also run UV run main.py. And now I'll first get asked for the topic, so the topic for that post. And I'll say open LLMs are amazing since you can run them for free on your local system. They're often more than capable enough for many LLM-powered tasks you may want to perform. So that's my topic. It could be shorter, it could be longer. This is what I chose here. And now if I hit enter, this will be put into our enhanced prompt and will be sent to the OpenAI API. And as a result, I got a generated X post, which is this one here. And that is an example for our first basic workflow. Obviously, as mentioned, not super complex, but you can see how you can interact with that OpenAI API and what makes this a workflow. It's not a generic chat. Instead, we have a clearly defined task here. We create our own prompt. We do some prompt engineering here, and we use that as a basis, as a foundation to have a reusable workflow, because now I could, of course, run this script as often as I want and generate more and more posts based on whichever topic I provide here. And that also includes short topics like AI will change the world, and I would also get a post for that. So in the previous lectures, you learned how you can send a request to the OpenAI API to interact with an OpenAI large language model. Now, I walked through all these steps in great detail because, of course, the goal of this course is to teach you how to work with APIs like this and to show you what's happening under the hood and what makes this here a workflow that specializes on one specific job. Now, as mentioned before, there are many things you can configure about those requests you're sending to the API, also depending on which API provider you're using. The official docs are the place to learn more about that, because in there you can also learn more about assigning different roles to your different messages, about sending a chat history. You can learn how to send images to the API to have the large language model analyze an image, or how you can get it to generate an image, how to work with audio and speech, and much, much more. Now, many of these things you'll see throughout this course. We're just getting started here, after all. But it's always important to dive a bit deeper into the documentation if you plan on using a specific provider or model, because of course, these APIs, the capabilities, and the capabilities of models of different providers change all the time. So use the official documentation, it is your friend. Now, when working with APIs like the OpenAI API, constructing requests on your own like this is absolutely fine. The advantage of this approach is that you can send a request like this in any programming language. Of course, the exact code would have to change. You would be using other packages, the syntax would be different, but the URL, the headers, and the payload would always be the same. That is, after all, the API you're interacting with. But when you're working with officially supported languages, if you want to call it like this, you also have the option of using an even simpler approach for sending those requests and extracting the responses. Because besides constructing those requests on your own, you can also use the official SDKs, the official software development kits. And it simply depends on the provider, which SDKs for which languages are provided. OpenAI here, for example, has examples for Python and JavaScript, though there, for example, also is an official Go library if you would be working with Go. It's just not in the examples in the documentation. But again, it depends on the provider which SDKs and libraries for which programming languages may exist. But here, if I do switch to Python, I can, for example, see that instead of constructing this request manually, as I did it before, I can also install an extra package, the OpenAI package, which is provided by OpenAI, then create such a client object, and then use that client to send a request, and also, and that's the best thing here in this example, to also extract the response in a way easier way than what I had to do here. So instead of diving into some nested objects in arrays and so on, when using the official SDK, there is an output text field on the response, which I can access to get quick and easy access to the received response text. So therefore, that's what I'll do here. I'll add the OpenAI package. I'll install it here into my Python project with UV-add. And with that done, instead of importing requests to send my own requests, I'll import OpenAI. Or specifically from that OpenAI library, I'll import the OpenAI class. This then allows me to create a so-called client by simply calling OpenAI like this. And that will then also automatically detect that OpenAI key if it's available in an environment variable called OpenAI API key. So I actually don't need to manually load it like this anymore. I just need to make sure that the .env file gets loaded. So this line is still important. And you could also always manually set the API key like this if you, for example, had an environment variable that had a different name. But if you're using this name, you don't need to do that. You can just create a client like this. And then with that, in generate xpost, I still want my prompt, but this part here changes now. Because now we can simply get a response by using that client. And now the suggestion here is actually for the old API, so I don't want to use that. Instead, now it's client.responses.create. And then to create, we pass at least 2 parameters where we tell OpenAI which model we want to use, and then again our input, our prompt. So here for the model, I'll again use GPT-4o, just like before, and for input, I'll still provide my prompt, also just like before. And now we can return response.output text because that's now a little convenience field we get on this response object because this response is now coming from that OpenAI SDK. And therefore that's now a bit easier. It's a simpler approach of sending that request and handling the response. And what's really great about this OpenAI SDK is that it can actually be used with many other providers as well, because it allows you to set a base URL, which you don't need to set if you're interacting with OpenAI, but which you can set to a different value if you're interacting with the API by some other provider which supports this OpenAI format. Like, for example, Google with their Gemini models. In their documentation, you also learn that you can use that same OpenAI package we're using here, and you just change that base URL to the Google API URL, and you set your API key, the Gemini API key then. And then you could use this OpenAI SDK just as you use it with OpenAI, though, at least right now, when I'm recording this, Gemini only works with that old API format. Again, the Gemini documentation is the place to go to learn more about that. But it's worth keeping in mind that the great thing about the OpenAI SDK is that it can be used with some other providers as well. Here, I'll use it with OpenAI though, and therefore that's all we need. So if I now save this again, and I then run my script again, I can again provide a topic. Like, for example, building AI workflows with code gives you way more flexibility than using no-code solutions. And again, a request will be sent. That's the same as before. It will essentially do the same thing as before, just behind the scenes, now with help of the SDK. And I get a nice little post, which I could now share on X. We did now get started with building a basic AI-powered workflow. And I chose this workflow because it's not super complex and it allows us to understand how we interact with the AI API, how we can use the AI model in our application. It is a specialized workflow because it's only about generating X posts, but it can be improved. And that is a crucial part of building AI-powered workflows. You wanna try to improve them, and often that means improving the prompt and performing prompt engineering and simply testing which prompts produce better results. Because right now, the X posts I get are still kind of generic. If I run this and I try to get a post on this topic, LLMs unlock many new business models, I will get a post, but it's pretty generic, maybe good enough. Even includes some hashtags here, even though I told it to not include that. So maybe it's not what I want. Therefore, prompt engineering matters. And one great way of achieving better results in many situations is to perform few-shot prompting. So besides assigning a role and having general instructions and using delimiters, few-shot prompting is one of the most powerful prompt engineering techniques that's able to dramatically improve the results you're getting. And few-shot prompting simply means that you include some examples into your prompt. So here, for example, I can say, here are some examples of topics and generated posts. Now again, I'll add a delimiter. It's technically not required, but I like to have it here to make it clear or clearer to the model where the examples start and end. And then I'll have another delimiter, topic, and generated post. And then I'll come up with some topics and posts I might want to share. So here I added 2 examples, and you could add more. And every example has a topic. So that would be the part the user would enter, the user would provide. And then I have a generated post, which is what I expect the AI to generate. I have that for each of my 2 examples. And even though it's just 2 examples, we should already get better results just because we added them here. Now, one thing I will add is some extra instruction here where I say, please use the tone, language, structure, and style of the examples provided above to generate a post that is engaging and relevant to the topic provided by the user. Don't use the content from the examples. So some extra instructions to hopefully ensure that it's really just the style of the examples that's picked up and not the content. And as mentioned before, prompt engineering is about simply testing different things and finding out what works best for you. So now we got a quite complex prompt, but that is one key part of building AI-powered applications. Prompt engineering is one key element of that. So now with that, if I again run this and I want to get a post about ShadCN, which is a UI library in web development, being the de facto standard for building web UIs in 2025 and telling people that they should learn it. If I set this as a topic and I send this to the AI models, I get back a post that is more in line with the posts I provided here as examples. And again, you could provide more and also tweak other parts of the prompt if you're still not happy with the result you're getting. So prompt engineering is important. What's also important to understand is that you're building this workflow, you're writing the code. I mean, that's the main thing of this course. That means you're in full control of that code. And that also means, for example, you don't have to put your entire prompt into the code like this. For example, these examples I added here are a great example, no pun intended, for content you could outsource into a separate file. So for example, I could add a post examples.json file, and in there add a list, an array of JSON objects, and JSON is really just text that's formatted in a certain way. And then in there, for every object, I could have a topic, which would be the text I have here, and my post that should be generated for this example, which would be this text here. I just need to make sure that I don't break it with all the line breaks. So I'll make sure that this is all one line here, like this. And I can also add the second post, like that. And then with that, we can simply load that file into our program and dynamically generate this prompt. We can load this file in read mode, extract those examples, and dynamically construct this examples text which we need down there in the prompt, like this. And with this examples string here, which includes all these examples, we can inject that into our prompt here, just like that. Simply to keep that prompt a bit shorter and outsource these examples into a separate file. Is that something you have to do? No, but it is something you can do because it's your code, you own it, you build your workflow. So with that done, we can of course still run that script just as before, define our topic, and get a post that is in line with our examples because those are still loaded, just in a different way. Of course, you did not take this course to just learn about simple, basic, one-step workflows, though the foundation, of course, is important. But here, we now got an example for a more complex, multi-step workflow where we'll actually also use different AI models in different steps. And you find the updated version of this workflow, the updated main.py file, also attached to this lecture. This updated version no longer asks for a topic as an input, but instead for a website URL. It then goes ahead and fetches the HTML content of that website by using the requests package again, sending a GET request to that URL. And I'll say right away that this approach will not work for all websites because there are many websites that have mechanisms to defend against requests like this, or websites that don't load all the content initially with the first request, which this request here would be, but which instead also load some content with client-side JavaScript code, for example, after the initial page load. All those websites would not really work with this approach. But there are many websites where this approach will work. So this will give us the HTML code of that website. And we then use this HTML code to actually extract the core content of the site. Because if I use my personal website as an example here, the HTML code of one of my posts can be seen if you inspect the page source, looks something like this. Not horrible, but quite a lot of code. I can scroll quite a bit to the right here. And of course, since it's HTML code, there are many HTML elements, CSS classes, and lots of stuff in there that's not relevant to us humans. The core text, which you see here, only makes up a part of the actual source code. But it's the overall source code, the overall HTML code, that's fetched by this step. Therefore, I also need a step that actually extracts the core content, the core text of this website, the core content that would also matter to us humans. And that's what extract core website content does. This step now actually leverages a large language model to perform this extraction because detecting the core text inside of a sea of HTML elements is non-trivial, especially if you want this to work with all kinds of websites, not just one clearly defined website. So you don't know the HTML structure in advance. And these are exactly the kind of situations where large language models shine. So again, I'm using the OpenAI SDK here, and then I'm using the 4.0 mini model here instead of the 4.0 model. I'm doing that because this 4.0 mini model is super cheap, way cheaper than the 4.0 model. And for tasks like summarizing text, extracting data from text, this 4.0 mini model is more than enough. It's absolutely capable to handle those tasks. But these are also the tasks that typically involve a lot of tokens. I mean, again, if you take a look at this source code, all this text here, all this markup is fed to the large language model. So all these HTML tags also consume tokens. So having a very cheap model is definitely important here, especially since, as mentioned, it's more than capable enough for this task. I then have a basic prompt where I instruct the model to extract the core text, excluding navigation, footers, and other non-essential elements from the received HTML code, which is received as input here. And then I return that extracted text. So hopefully the text that's relevant to humans. Once I have this core content, I have another step here which actually summarizes this content, because in the previous step I extracted all the text as it appears on the website. Now I want to create a summary based on this text. For that, I again use 4.0 mini because, again, for tasks like extraction but also summaries, it's awesome and it's cheaper than other models, so that's why I'm using it. Have a simple prompt, pass my content, the extracted content to it, and then hopefully get back a summary which I return. And it's then this summary which I again use to generate an X post. I also log the summary and the core content for debugging purposes. That's my workflow here. Again, leveraging large language models, but different kinds of models. 4.0 mini for extraction and summaries, but for post generation, I'm still using 4.0. And therefore, here, I can again run this script, paste in a URL, like here, the URL from my own website, from this article, and then it'll go ahead, fetch that content, send it to the large language model. And this can take a while because it is a lot of content to parse and process. So now the model is doing its work, trying to extract the core content. Here we go. That is the core content it detected, the core text it extracted from all that HTML code. Looks pretty good to me. Then it's summarizing it. Here is the summary, a bunch of bullet points, because in my prompt I told it to prefer bullet